Okay, everyone. So thank you very much for joining. We're going to start right now. Just to let everybody know that the event is being recorded, so this will be available for anybody that joins later or that's not able to make it, or anybody that wants to share it. This will all be recorded. Just a short presentation. I am John Lizarraga, and
I'm Sonia Olza.
We are members of Iniciativas Innovadoras, one of the partners of the STRATUS project. We're in charge of communication and dissemination efforts. And you're going to hear very little from us because you will hear from all the other partners that have all the knowledge about integrated fertilization management. So that's it for us. Paula, if you want to start presenting, we'll shut up.
Yes, sure. Many thanks, John and Sonia. Okay, I think everybody can see my screen. So good morning, everyone. I hope you are all doing well. As I said, John, my name is Paula Resano. I work for INTIA and currently as the project coordinator in the STRATUS project. I'm really happy to welcome you all because this is our first online event. Today, we are here to present some preliminary results from the project, but also insights about precision farming, soil quality techniques, and bio-based fertilizers, focusing always on optimal fertilizer use. Throughout the event, we will discuss on how precision farming, bio-based fertilizers, and soil quality practices can help us to make a better management of fertilization in farms. I will begin with a small introduction about the project, and then we will continue with 3 thematic sessions. In the first one, Alessandra Gemmiti from the government of Regione Toscana, Simone Kartsiotis from AgroBit, Alexandros Fournarakos, and Georgia Nikolakopoulou from the Agricultural University of Athens will explain us how drones enhance precision farming and how we can use them for input optimization, and they will give us case examples. Then we will continue with Williem van Geel from the Wageningen University and Research, who will explain the concept of fertilizer replacement value rate and how they address it in manure management in the Netherlands. We will end the expert sessions with Cecilia Hermansson from the Rural Economy and Agricultural Society in Sweden, who will talk about soil quality techniques and how to integrate them into everyday farming operations, more specifically about biochar and how we can use it as a carbon sink. After these 3 sessions, we will have a panel discussion where you will have the opportunity to ask questions to these experts. To finalize, Clemence Monod from Vegepolis Valley will present us some results from STRATUS related with the former topics collected as so-named good practices. So let's begin with no further ado. Funded by the European Union, STRATUS is made by advisors for promoting optimal fertilizer use. The project started in February 2023 and will last 5 years. We are a consortium of 15 entities with different grades of expertise in agricultural research, governance, consulting, and advisory services for sure. What we are doing. In a nutshell, the project aims to connect advisors from all over Europe for accelerating knowledge creation and sharing on the topic of integrated fertilization management. But more in particular, STRATUS seeks to create a sustainable European-wide advisory network that will gather, evaluate, and disseminate existing solutions for optimal fertilizer use. Also, we want to facilitate the knowledge transfer and the innovation adoption process by integrating advisory services into all the agricultural sectors in all the European member states. Also, we want to reduce farmers' dependency on mineral fertilizers, and we will do this by promoting other alternatives such as bio-based fertilizers or by the use of precision farming techniques. So we would like to have policymakers more involved so we can support the policy development of, so we will engage them in discussions about nutrient management and fertilizers policies. And to finalize, we want to ensure the long-term sustainability of our network, and we will do that by embedding it within national and regional advisory systems. Those were our goal project, or project goals, but our project also supports the Farm to Fork strategy. Farm to Fork strategy aims to reduce nutrient losses by 50% by the year 2030, by cutting fertilizer use by at least 20%. STRATUS helps achieve this goal by the following, that you can see the screen. We will develop guidelines for drawing nutrient management plans, and we will create a digital platform for sustainable fertilization to host a lot of knowledge objects also about different topics, not only sustainable fertilization. We are training farm advisors to apply innovative fertilization techniques. So we are encouraging the use of bio-based fertilizers from waste streams, and this itself supports the circular economy. So we promote precision farming to optimize nutrient application and reduce excess use. Besides, apart from the Farm to Fork strategy, we are aligned with the European Biodiversity Strategy, which emphasizes, among other topics, soil health and the reduce of nutrient contamination. We contribute to this by reducing nutrient runoff to prevent soil and water contamination, enhancing soil organic matter through sustainable fertilization techniques, such as the use of bio-based fertilizers. And also we are promoting agricultural practices that power biodiversity in agricultural ecosystems, such as cover cropping or crop rotation. So many thanks. That was the part related to our project. I hope everything is clear. Now I will give the floor for the session part of the event. Thanks.
Thank you, Paula. Before Georgia starts, I just wanted to remind everybody, I forgot to mention that you can now use the Q&A function or the chat to pose any questions that you have. As Paula said, there will be a panel discussion after the 3 thematic sessions. So we will compile all your questions and answer them during the panel discussion. But you can start putting those in there at any time. All right, Georgia?
No.
Oh, sorry, Alessandra, your turn.
Okay, thank you very much, Paula, for your presentation, and to John, give me the floor. Try to share my screen. My presentation will be on the top, is on what Toscana does to implement the precision farming. So the activity that Toscana region carries out on precision farming in the region, in Italy, and in Europe. Share what? Okay. Presentation là. No. Okay, is that fine? Can you see that?
Yeah, we can.
Okay,
Alex.
thank you. Thank you. So what I'm telling you are the activity and commitment of Toscana region to support precision agriculture. I will leave the technical and research information to the university and people that knows better than me. Okay, precision agriculture, it's not something new for you, but it's a necessity and not a choice. The diffusion of innovation, the use of digital technology, and the improvements of digital skill in agricultural field has a leading role in national and regional policy. because of course regional and national and European policy are important to put in place the activity for the digital technology. The need to improve the environmental, economic, and social performance in rural areas asked for farm modernization. In the framework of European, with the Green Deal, and already said Paula with the Farm to Fork strategy, the goal of the Commission is to have to reduce climate impact, but at the same time to have more efficient competitive competitive economy in terms of resources, in which digital technology, research and dissemination of innovation are basic tools. What we do and our is the strategy to activate and to promote better precision agriculture. So in our S3 strategy, smart specialization strategy, we introduced smart agri-food application area. So we guarantee in this also in this program the activity on smart agri-food. We created in the region community of practice on precision farming, and we promoted cooperation of projects from rural development program we call last measure 16, but you don't mind maybe the measure, and the cooperation project without simply cooperation of projects, and the investment project we dedicated completely to precision agriculture with 8 million euro. New programming period we organized in the region, but also coordinated the activity in Italy with the region in Italy that wanted to apply this agro-environmental intervention that we call AK24, and that's on precision farming. And then December, we call for other intervention to support the operational group of European Partnership dedicated also to precision farming. At European level, we work on this topic, we saw high-tech farming in area network, creating working groups. I don't know if you know area of network, but it's a network of European Region for Innovation, Agriculture, Forestry and Food. And inside that, we are about 1993 members from different regions and, of course, country. And we are connected with other networks, European networks. So we have a big platform to work with. And inside the area of network, we created the working group of high-tech farming because we thought that was important, and we have a big group of region working with us. And also we created the S3 agri-food platform high-tech farming. At the moment that's under the DG Regio hat, and we have about 34 regions. And in the S3 agri-food platform, we don't have all the regions, but also research institution and SMEs and farmers and everybody. So it's not dedicated exclusively to the region. What's community of practice? We created in 2019 is coordinated by Ente Terre Regionali Toscana because we thought was very important to communicate with all the stakeholders in the region and also outside the region if they wanted to. At the moment, we have under 9 entity among university, research organization, farmers, SMEs, cooperatives, and association, and everybody. The community of practice aims to encourage and facilitate the process of modernization, training, and transfer of innovation to farmers and agricultural sector by strengthening the links between research and practice. So we try with this. We hope to reduce the gap between research and information from other area with farmers. And the central role to do this is the demo farm. So the demonstration farm, that's a place to test, transfer, and innovation solution. With the new rural development program, as I said before, we organized the agri-environmental climate measures, and we made a call of that that offers to the farmers an annual contribution per hectare to utilize agricultural area. The commitment for the farmers is to keep the activity for 5 years. The total premium per eligible cultivated hectare is determined by commitment across action and crop groups. So we divide it in 3 actions: precision fertilization, precision phytosanitary treatment, and precision irrigation. And the premium depends on cultivation, so field crop, vegetable crop, or permanent crops. And as an action 1, as you see, is referred also to the activity of STRATUS. One thing I forgot, that in the community of practice of high-tech farming, we created inside that the community of practice on fertilization for the activity of the STRATUS project. Back to the agri-environmental climate measure, the commitments is to access the digital divide platform and DSS in agriculture, implement precision intervention and appropriate equipment, maintenance of soil health through the commitment period, 5 years, as I said, farmers training and advisory service. That's very important. It's not the last, but it's very important. So what we have at the moment is about 12 operational group on the precision agriculture. And out of 68 integrated value chain project, we have 16 related with precision agriculture. Other 40 innovation project measure, that's cooperational measure, have been recently approved, and on 40 we have 14 on precision agriculture, and also we have other projects supported by European Regional Development Fund project on precision agriculture, obviously. As you see here is just a resume of sustainable resource action that I said before, with the reduction of chemical and water inputs through the adoption of precision farming practices. And the digitalization of agriculture and the use of decision support system aim to support the correct use of resources and the management of a situation that change quickly, as occurs in the context of fluctuation brought about climate change. Of course, as we say in Italy, there are not roses and flowers. We also have barriers, and everybody knows that costs are not accessible to all farmers. And in Italy, but I believe many country has a small small farmers, small hectares for farmers. And so to help do not have these barriers, we put in place promotion of innovation. For lack of knowledge is another barrier, and so we promote training system. And for transfer of innovation, we have calls on the advisory, but that's what we want to do also in the STRATUS project. A collaboration is in finding solution. We promote a community of practice. That's a place where we share needs and information and innovation and collaborate in co-creation activities. The region takes on a leading and supporting role to promote the modernization process, to break down the digital divide, both in terms of logistics and skills, by bringing together different but connected realities.
Hi, Alessandra. Just a quick note. I'm sorry. They're asking us if you can put the screen, share the screen in full screen mode rather than the presenter's view, because they cannot see it big enough.
And just sorry, because I see in postation. I see that I don't know why because I should put two computers. One I see on wait, I don't know. Sorry, I don't know.
Okay. And then just turn note that we have like 1 minute left before we move on to the next speaker. Okay.
1 minute.
Okay.
Okay, so the last thing I would like to say that besides of area of network where we have a working group on precision agriculture, we also created, we have with the support of DG Regione Joint Research Center, we created the S3 Agri-Food platform. That's a platform, I don't know what's happened now, but I cannot, okay, we can just do this. S3 Agri-Food platform on high-tech farming is very important because in this platform we do not have only regions, but have many the stakeholders are working on that, on the precision agriculture. So as you see here, but you will have the presentation. We have different activities. And okay, I will not tell you about everything on S3 COP Secretariat that helps us on this platform. And at the moment, we asked for the service offered by them. We are working on demonstration because we believe it's very important to transfer the innovation and the innovation already proved. Okay, this is the events. I think I'm in time, and I thank you very much for the attention.
Thank you very much, Alessandra. We're going to move on to Simone right now. If you want to start sharing your screen.
Yes, thank you. Also, I want to thank all of you and all the STRATUS consortium, and also Alessandra to invite me to talk about precision farming. I am the CEO and co-founder of AgroBit. AgroBit is a agritech startup that develops digital farming solutions for farmers and technicians. Basically, our vision is to democratize the access to all these technologies. So making these tools much more accessible to every farmer. And also, our mission is to help farmers and technicians achieving the environmental, social, and economic resilience and sustainability goals. And we do that by exploiting especially imaging. So what we are doing is developing decision support systems based on the imaging from smartphone to drones. We have also different services related to yield monitoring or crop monitoring with drones that I will talk much more in the next slides. And also we have an important part relating reselling different technologies and also training for schools and professionals. So we are developing image-based DSS. So as I say a few seconds ago, we exploit different optical technologies from smartphone to camera mounted on tractors and drones. So we collect these basically images and extract information and metrics from crops, from different kind of crops, of course. We have also a mobile app called iAgro, which basically allow the creation of a digital twin of crops using the smartphone like a 3D scanner. So the app was born exactly to allow also small farmers to digitize crops and get metrics and information to optimize, especially fertilization and pesticide treatments. And on the other side, we have two services, iTractor and iDrone. iDrone is the service that I will talk much more about in the next slides. So basically, we have a fleet. So we have a drone fleet, and we do the services, but we can also only process the data. So basically, the monitoring with drones is not the much important part. We extract different information, so from multispectral thermal images, but also from visible images. And then we create zonation maps based on vegetative vigor, water stress, also other parameters. For us, the drone is an important agronomic tool to monitor also big fields. So it's something that can acquire very fast, lots of information. Then we can exploit all this information and using both 2D data or also 3D data, so 3D models. The final goal, of course, is to create a map. Basically, a map is something that can guide better agronomic decisions. So this is why it's important to use this kind of technology to understand much better what is going on in the field and also to take much more informed decisions. So basically, we have different case study and also clients that were able to reduce the cost of chemical inputs, water, but also reduce the time to get the information, because manual information in such fields, especially in European countries, there are lots of fragmentation of fields, so it's difficult also to collect information directly from the field. The drone can help a lot. Also, we are involved in different research and development projects in the Horizon Europe and framework, but also rural development programs. So both regional and European programs. And today I will also talk about the AgroTeam projects that has developed in a cascade call of the Icarus Horizon Europe project. This project for us was very interesting because allowed to demonstrate that we can use also low-cost drones, RGB drones, so only collecting visible data to get lots of metrics and information about, in this case, vineyard, but can be extended also, of course, to other tree crops, or also horticultural or cereal crops. So basically, the aim of the project was to assess the canopy biometrics and other field parameters, especially to optimize the treatments, so to create maps for variable rate treatments. This, of course, is in line also with the European Green Deal targets to reduce and optimize the use of chemicals and water. So basically, we developed a DSS based on computer vision and AI algorithms. A DSS is simply a black box that takes into input some information, as you can see here. So, of course, RGB images from drone, other information about the vineyard characteristics. And then in output, we have different parameters like canopy biometrics, so thickness, height, and volume of sampled vines. So we can use basically the 3D model to like a digital twin. So we can use it to extract lots of information. So going beyond the 2D representation, the classical 2D representation of a photogrammetric survey by drone, we can go beyond and also study much more in detail the information on 3D models. Here you can see, for example, a sample vine, a test vine from in 3 different dates. So you can see here the 7 parameters that we extracted for automatically. So we have an algorithms that, based on the vine position, vine GPS position, extract automatically all this information. So the thickness, date, the volume of the canopy, leaf area index, leaf wall area, tree row volume, and also there is a phytosanitary a pesticide model to assess the optimal water for pesticide treatments in liters per hectares for the different phenological stages. So basically, we use the 3D model and the digital twin to extract metrics, numbers, not only qualitative parameters, but exactly the numbers. Here you can see we sampled in some points the vineyard. We had also 2 different parcels, one test and one control, because we did also variable rate pesticide treatments in the 2 parcels. And here you can see the leaf area index, so basically a vegetative vigor map in the 3 dates, and the 3 prescription maps for optimized pesticide treatments. The leaf area index maps can be used also for fertilization, so for variable rate fertilization, giving much more fertilizer in the white areas and less fertilizer in the greener areas. You can see here, I will show you some also real case study with some of our clients. In this case, we are in a vineyard. We in this case, the company is using these maps from 4 years now, and every year we go there and we do the acquisition of the vegetative vigor information. So basically, we create 3 classes vigor map to highlight the different areas in the field. And it's very interesting in this farm, in this winery, that in September 2022 we did it was actually the 2nd year where we could see differences in the different vineyards. That based on this map, they did in the autumn 2022 the variable rate fertilization, and the next year we can see better homogenization of the vegetative vigor inside each vineyard. So the aim of this winery was to optimize the fertilization to get a better yield of the grapes. But if we go also in the 3D environment, so not only 2D maps, but also 3D, we can also create the digital twin to assess the biomass volume of the canopies inside of these two different plots. The green plot was a plot treated with an innovative fertilizer. It was a 1 hectare plot with a canopy volume about 20,000 cubic meters of canopy volume. On the other side, we have the red plot, which was treated with a standard fertilizer. You can see here from the numbers that the red area is bigger, 50% bigger than the green area, but it has 30% less of canopy volume. So the drone can assess exactly in numbers if we can use innovative fertilizer, for example, or to demonstrate that some innovative products or fertilizers has a better effect on, in this case, vegetative vigor, so leaf area, basically. From drones, we can also create different maps from multispectral, but also thermal maps to optimize also water stress, so irrigation. In this case, we are in South Italy. It's almond, intensive almond field, and this one on the other side, it's a super intensive almond field. And you can see the different maps that we can create. So from the visible map, basically, you cannot see nothing about the health status. If you go in the multispectral and also thermal, you see that there are different areas, and you can manage these areas in a site-specific way to optimize the quality of the yield of the final product. Also, in this case, citrus orchard in Sicily. So basically, we applied the Icarus AgroTwin project algorithms in this case to extract every tree, analyze its canopy, and assessing canopy density, thickness, height, and volume. And it's very interesting to see how 3D information can be converted into 2D maps containing 3D information. So you can see here, for example, canopy thickness map, canopy height maps, canopy volume maps. So with the drone, we can go at a very high detail, so at the tree level, basically. Can be not important in many applications, but this is the quality and how much we can go in detail to assess also metrics, so numbers about each tree, basically. Of course, we can do the same with the tree row volume information and DVI. Also, we can make mean values if we are interested in this case, where the plots were made of 4 trees, but in general, we can also spatialize much more this information to get more practical maps to optimize the different operations like fertilization. Thank you, and if you have some questions, I'm here.
Thank you very much, Simone. Again, if you have any questions for Simone or Alessandra, you can use the Q&A feature and we'll respond those later during the panel discussion. Quick reminder now to the next speakers to please keep the presentations as concise as possible. And Alex, I believe it's your turn now.
Thank you very much, John. All right, so I'll try to keep this short. Hi, everybody. I'm Alex, Alexandros from Fournarakos from the Agricultural University of Athens. Today I'll be presenting the Icarus project. Simone happened to just mention it, so I'll just very quickly go through what the Icarus project is about and how it can be linked to integrated fertilizer management. So just a few words about Icarus. It's a 4-year project. It started in 2022, so we're actually in our 3rd year almost of operations. The entire title is Innovations and Capacity Building in Agricultural, Environmental, and Rural UAV Services. In case you're not aware, UAVs are unmanned aerial vehicles, so basically drones, and how they can be used in many different scenarios. The vision behind Icarus is researching the available drone intelligence there is out there, so taking stock of drone market products and services, developing and demonstrating our 5 use cases, which we will see in more detail later on, educating and training through our academy and our digital platform, which are used to train stakeholders in all matters drone related, from their actual operations to business models and ways to leverage drones. And scaling up to build a network of drone stakeholders and all sorts of different projects that can be linked together to boost and amplify the impact of the project. So what exactly are we developing? We have 5 use cases that are producing data and doing different activities. All of those use cases are linked to drone usage, of course. And we're using all that information in order to create a holistic drone market landscape, create models that can be used for analytics in drone operations, have different socioeconomic and environmental impact assessments on the use of drones, create business and governance models for policy and for different business applications, create the Icarus Academy that is used to train people and educate people on the use of drones, and of course the Icarus platform, which is a bit of a centralized hub that hosts all of these different findings. So we have 5 use cases in Icarus. As you can see, they're based all across Europe, and they have a quite wide variety and a lot of diversity in what they are currently doing. So we have one in Greece on drone spraying and use of plant protection products in vineyards and rice. We have the rural logistics use case in North Macedonia, which has to do with delivery of cargo using drones. We have the forestry and biodiversity in Lithuania, which has to do with monitoring wildlife and monitoring forest fires. We have the livestock monitoring use case in France, which has to do with tracking animal movements and production animals. And we have the crop monitoring use case in Spain, which is the one we will be talking about today. So our crop monitoring use case is led by Numena and EI. It's based in Tarragona, close to Barcelona. And it has these overarching objectives. So Numena is studying the growth patterns and the environmental conditions for vineyards. So essentially, they're trying to find out how stress levels, disease levels, how soil types and soil health impact plant health, right? This is done through integrating different models and solutions through drone surveillance to detect what problems might arise in a crop field. So essentially being able to find out through their drones, through cameras embedded on their drones, if there's something wrong with plant, if there's diseases, if there's pests, and so on and so forth. So they then use a platform that they are able to understand what exactly is happening inside the vineyard by assessing all those different parameters. I'll try not to go into too much detail on the technical things, but there's a wide variety of data that is being collected, from weather data to multispectral images from cameras based on the drone as payloads, RGB images. So all of those different things can be used to assess and analyze the data in order to understand what the state of the vineyard is in terms of health and all different. So as you can see, there's many different types of data collection, which is what makes this use case quite complex and quite interesting, which has to do with top view flights. So the drone goes over the vineyard. Row view flights, the drone goes between the rows of the vineyard, and manual studies like collecting leaves, soil samples, which can be used to then assess fertility, soil health, and soil quality. As you can see, a lot of different things can go into this in order to detect diseases, label the plants in terms of health, label the growth and the yield, and that can also be used to create algorithms for training in deep learning models. So as you can see, this is how the data is collected from different parts of the vineyard. The different characteristics are then assessed, and you can make an analysis. This is a very brief presentation, so I don't want to take up more time, but you can reach out to us if you have questions regarding these two use cases, and we can bring you in touch with Numena. And the outcomes so far have to do with being able to understand if a plant is healthy, what the levels of the diseased plants are, how far along the diseases are, if the plant is stressed from lack of nutrients or lack of water. So a lot of these things can tie into fertilization in order to understand if fertilization is actually having an impact, a negative or positive impact on the cultivation. So that is all. For any questions, as John said, you can leave them in the chat. And yeah, thank you very much.
Thank you very much, Alex. Moving on to Georgia. Georgia, I know that we just started, but we're running a little long, so try to be concise, please, but always, making sure that you deliver the message.
I'll try to be brief. Let me tell you if it is in the presentation mode. My presentation?
Okay.
Is it? Yeah, perfect. So, good morning, everyone. I'm Georgia Nikolakopoulou. I'm from Agricultural University of Athens. In my presentation, we will dive into the application of for input optimization, including the fertilizers. However, we will focus on the baseline because we have in this meeting mostly advisors and farmers who are probably interested on knowing the most baselines for applying new technologies. So we will also present some case studies and live examples of drone technology in agriculture, as already Simone has presented. So it is very important to understand very briefly what is precision agriculture. So the main focus of precision agriculture, or you can also find it as smart farming, is to use data-driven tools to optimize the decision-making across different farm operations. So by using new technologies, we can increase the yield volumes, we can mitigate the workload for farmers, which is a serious problem in the European Union. Also to contribute the climate change adaptation, and you can understand it as the European Union also tries to fund new projects that has this goal. And of course, we need to ensure that we have the future of agriculture for the coming centuries. So if we would like to be practical, the main goal of precision agriculture is to optimize the returns on the inputs while preserving the resources. So the main benefits of precision agriculture, I will try to be brief because we have already presented them, are mostly economic because we can have water, energy, nutrition, labor, and agrochemical savings. And it is very important to understand mostly the farmers and the advisors at all these points are interdependent. So it means that if we would like to improve and have a nutrition savings, we have probably to start from the water savings. Going to the environmental topic, we can reduce the greenhouse gas emissions, we can reduce the pollution from chemicals, also the soil degradation and erosion, and of course we can ensure the biodiversity and environmental potential. And also it is very important that by using new technologies and determine, let's say, with numbers and have a history of the inputs we used in our farm, we can have higher quality products and agricultural product security, of course. And as you all know, from the customer, it is more than appreciated when they have the traceability or they can ensure the safety of the final product. And as a result from all of this, we can ensure the well-being of the farmer and of course of the customer. So the most important technologies that we use in precision agriculture is the GPS that we all know from our smartphones, the drones, the satellites, the control system, the sensors, and the robotics. And we will dive into the drones and how we can use it for a better decision making. So the drones, and as Alexandros mentioned previously, we can also find them as unmanned aerial vehicles that can be used from operators without carrying an operator inside. So if we focus on the agricultural drones, they can be controlled either autonomously or with onboard computers and sensory instruments, or, and this is the most common, by remote control from an operator on the ground or in another vehicle. So we can use the agricultural drones for plant protection, for crop monitoring, for forestry monitoring, etc. If we want to apply fertilizers by using precision fertilization and by using drones, we have the spraying drones and the monitoring drones. The spraying drones are equipped with advanced spraying system designed for targeted crop application, of course. We can apply pesticides and fertilizers, and the main goal is to reduce the waste and minimize the environmental impact. But be careful, because the EU law is very strict, and only in some EU countries it is allowed under strict conditions to use drones for fertilization, and mainly for the liquid fertilizers. So if a farmer or a licensed operator, an advisor, whoever would like to use them, they must obtain special approval from National Aviation and Agricultural Authority before using drones for fertilization. So that you can go just buy a drone or rent a drone and start applying minerals. So after this slide, I'm sure that you're questioning, so why do we care about the drones in precision fertilization? We can use monitoring drones and make maps, as Simone, Alexandros presented previously, to make better decisions. For example, we can use a drone equipped with a multispectral camera, and we can, by the reflection of the crop, make some different zones, understand if some parts of the field are healthier, maybe some others are more stressed. So in the most stressed areas, we probably need to go there and understand why, and of course apply probably more fertilizers, or if there is a problem, for example, it is less irrigated, we need to change firstly the irrigation program, and then finalize the fertilization program and strategy that we will follow. So we can record the vigor, the soil health also. We can also use data regarding the weather, but it is very important before starting applying using drones for making a better strategy and a better decision for the irrigation program, for the fertilization application, etc. It is very important first start by using other techniques like ground-based measurements, like sensors, soil sensors, moisture sensors, nutrition sensors, because we can't say that only from an image from a drone we can have a final decision. We can do it only if we have many historical data, we know very well our field, or if we're an advisor, our customer's field. So later on, when we have an experience on a specific field, we can use probably only data from a drone. We can also use these maps that we previously described. It would be more or less like that. This is an NDVI map, a normalized difference vegetation index, and we can use it and feed a tractor to apply different doses of fertilizers. If an advisor or probably farmer is interested in making at least these maps, it is very easy. You can use only open source softwares like the QGIS. There are plenty tutorials on the internet that you can find, many seminars. So you can just follow methodology, a pipeline, and if you have data from a drone, you can make maps like this. And also an important part is mostly for the farmers that they are afraid of their data because the data of their field owns to them. So the European Union and especially the General Data Protection Regulation sets global benchmarks for your data. This data from your field owns to you, excepting you sell these data sets to a company or to anyone else as a product. Following the use cases that Simone and Alexandros and Alessandra presented previously, we will present the easiest way to apply precision agriculture based on the drones. So the first example is from Greece. It is a drone-based field analysis for precision nutrient management. This is also an NDVI map. You can see that it has a different color from the previous one. It is based on what the person who makes the map prefer as a color palette. So we made this the NDVI maps to use them in a tractor from a company in order to apply different doses of fertilizer in an olive orchard. This is also an example from an experiment that we are doing in the olive orchards and vineyards in Peloponnese in Greece. We applied fertilizer with a sprayer drone. Of course, as we previously mentioned, we had to ask for special permits from the authorities as the Agricultural University of Athens before we are applying the fertilizers with drones. The experiment is focused on the uniformity of the fertilizer across the field. If we can have positive outcomes and reduce the cost of the labor, and of course, as we most of the times we have problem to reach some areas, mostly in the vineyards. If it is a good solution than the traditional machinery that cannot go to these areas. And of course, we have to be careful with the windy days. We have to avoid going and spraying these days, not because we are afraid of the drone, because it's a heavy equipment, but mostly to prevent the drift and the inefficiencies. And last but not least, it is the role of drones on organic broccoli farming. We made a combination between data we had from a multispectral sensor equipped in a drone. We combined them with data from sensors in the field. This sensor was for moisture, for nutrient level, and temperature from weather stations, and we feed this data to an AI model, which would be about to give us specific suggestions for the final strategy that we can follow for the fertilization of the field. We chose the broccoli because it's a high nutrient demand crop. So if at the end of this project we have positive results, of course, we can apply it to other similar organic farms or not with high nutrient demand needs. So this was from my side. I tried to be brief.
Thank you very much, Georgia. I know it's not easy to run through it, but thank you. So that concludes the session 1 about precision farming. We're moving on to session 2, from waste to wealth, bio-based fertilizers transforming farming. in which Willem will talk about the fertilizer replacement value rate of animal manure and why this is the most important bio-based fertilizer in the Netherlands and how this affects runoff. So Willem, if you want to start sharing your screen, the floor is yours.
Okay. Can you see my screen now or no?
Now we can. If you want to put in presentation mode,
Yeah.
There it is. Perfect.
Yes? Okay. Yeah, I want to tell you something about how we deal with manure as a fertilizer in the Netherlands. And yeah, what I want to tell you is one of the questions that I got is what makes manure an important bio-based fertilizer in the Netherlands. And then I want to focus on how we deal with it in a fertilization plan. And you need to know what is its value compared to chemical fertilizers and how can you determine this. And I will tell something about the environmental impact by the use of manures. That's mainly the risk of volatilisation of ammonia and nitrate leaching to the groundwater and the surface water, and how you can reduce these risks. So yeah, the first question, why is manure such an important fertilizer in the Netherlands? I think the answer is quite simple, because we have plenty of it. And actually too much. I've shown you some figures of 2022. Situation at the present moment has not changed very much, but we have about 1.8 million hectares of cultivated area that is used for agriculture. Almost 2/3 of this is meant for grassland and fodder crops. And the main fodder crop is silage maize. About 30% is used for arable crops, and then 5% for horticultural crops. You can think about the vegetables for the fresh market, or fruits, or flower bulbs. And 1% is used for horticulture in greenhouses. And at the right side, you see the production of nitrogen and phosphate from manure in 2022. And you see that almost ample 450 million kilograms of nitrogen is produced by animals in the Netherlands, by livestock, mainly by cattle, but also from intensive livestock farms, pigs and poultry. We still also have a lot of manure. And if you divide this by the cultivated area, then down you can see how much nitrogen and phosphate you would have to apply to get rid of all this manure. But of course we cannot use manure in all the crops, especially not in greenhouses, but also not in many vegetable crops. So when the manure has to be applied on the grassland for the crops and the arable crops, then yeah, you see that you would have to apply about 275 kilograms of nitrogen per hectare and almost 90 kilograms of phosphate, which is too much. That actually we have a surplus of manure in the Netherlands, and you cannot also, the livestock farms, the dairy farmers have of course have the grassland on which they can apply the cattle manure, but the amount that they can apply is legally restricted. And the intensive livestock farmers with the pigs and the poultry often do not have much land of themselves, and so they have to get rid of this manure. Also, the dairy farmers have to get partly rid of it, and yeah, it's a game of we call it the market. It's when there is more the product offered then people ask, then you get low prices. And in this case, in the Netherlands, because the livestock farmers have to get rid of it, and the arable farmers want to receive it, but they get paid for it. So arable farmers get money to receive manure. And that makes it very attractive for them, because it's first of all very it's an income. They call it receiving manure. It's an income for them. So it's of course a very cheap source of nutrients. It contains nitrogen, phosphorus, potassium, also micronutrients. We also know from manure that it improves the soil fertility because it contains a lot of nutrients, and it contains organic matter, and that contributes to the maintenance of the organic matter content of the soil. So these are the benefits of manures, of using manure in the Netherlands, especially for the arable farmers. But when you use it as a fertilizer, you must know what is the fertilizing value of it. And we call it the fertilizer replacement value of manure. When the fertilizer recommendations that we have in the Netherlands for several crops are all based on trials that are carried out with chemical fertilizers. So you need to know what is the value of the manure compared to chemical fertilizer. That's what we call the replacement value. So that's the part of an element that has the same effect on the yield and the nitrogen and the uptake of nitrogen and phosphorus as a chemical reference fertilizers. And these reference fertilizers for us are calcium ammonium nitrate. Most of the trials are done for adjusting we call it for investigating the necessary recommendations are carried out with calcium ammonium nitrate, and for phosphorus with triple superphosphate. And to give an example, when you apply 100 kilograms nitrogen with manure, and you find in a trial that this has the same effect on the yield and nitrogen uptake as 70 kilograms that is applied with calcium ammonium nitrate, then we say the replacement value is of this manure is 70%. But what actually does determine this, for example, this nitrogen fertilizer replacement value? That's the most important one. First of all, this is determined by the ratio between the ammonia, the mineral nitrogen in the form of ammonia, and the organic nitrogen in the manure. And at the right-hand side, you see a little example. For example, pig slurry and cattle slurry are the most used manures in the Netherlands. Also have the biggest volume of it. And you see that about 50% of the nitrogen in this slurry is in the form of ammonia, and about 50% is organically bound. But on the other hand, when you take a look at solid cattle manure with straw or a solid chicken manure, then you see that only about 10% is in mineral form, and the rest is organically bound. So what? First of all, when we look at the mineral part of it, the ammonia, what remains available for the crop after application depends on the application technique. For example, when you spread it on the soil and it remains there on the surface of the soil, a lot of ammonia can get lost by volatilization, and when you incorporate it in the soil, these losses are much lower. But the volatilization also, of course, dependent on the weather circumstances at the moment of application and just thereafter. When it's sunny weather and there's a lot of wind, then the volatilization is relatively high, and when it's raining, there's no volatilization. And the other part, so the organic nitrogen, what comes available for the crop, that depends on the mineralization rate of this organic matter or nitrogen. I will tell you some more about it in the next slide. But furthermore, the replacement value, or what we say, what the amount of nitrogen that comes available for the crop, also depends on the uptake period of the crop. When you have a crop that's with a long growing period and a long nitrogen uptake period, this crop can benefit more from the mineralization of the organic nitrogen than a crop with a short growing period. We have some guidelines in the Netherlands that but we have put it on a website that's called, I see it downstairs, so it's a website called Handbook for Soil and Fertilization. And there are all kind of guidelines for the for fertilization that farmers can look up and use. And for estimating the replacement value of this mineral fraction of manure, as just said, it's dependent on the application technique, also on the weather circumstances, but this you cannot predict. So we have rough guidelines or average values that we say when you inject the manure, the slurry in this case, because solid manure you cannot inject, but when you inject slurry or urine rather deeply into the soil, approximately 15 centimeters, then 95% of this ammonia nitrogen remains available for the crop. And this is directly available nitrogen. Salt injection, or you can also call it a more undeeper injection, is then you have more losses by volatilization, and then only 70% remains available, and so on. When you for solid manures, when you spread them and incorporate them immediately, then the 80% remains available, but when you wait for 1 hour, then the losses are a little bit higher. So the second part, the organic nitrogen, it becomes available for the crop during the growing season by mineralization. And in the past, a lot of trials have been carried out to determine the replacement value, especially of this organic part. But yeah, as I told you, it depends on the type of manure. It depends also on the uptake period of the crop. And with this all this data that are gathered in past research, the mineralization now is predicted by means of a model. To tell you later something about it, but the mineralization depends on the type of manure. It's because if it's pig manure from pigs or cattle or chickens, the rate of the stability of the organic matter of this manure differs, and also that means that the mineralization rate can differ. Temperature, of course, has an important effect on the decomposition of organic matter. And furthermore, it's the moisture content of the soil, oxygen, the acidity of the soil. These are all factors that influence the activity of the bacteria that are involved in the composition of the organic matter. Also, the carbon-nitrogen ratio of the organic matter is an important parameter. When the CN ratio is lower, then the mineralization rate of the manure is higher. And when the CN ratio is higher, then the mineralization rate is lower. And yeah, well, all this kind of information is used to develop and calibrate a model to predict the mineralization. This model is called MINIP. And the advantage is that when you use the model, then you can predict the amount of nitrogen that is available from the manure for many different situations, and you do not have to do trials for each individual situation. So the input of the model is a so-called A value, or they also call it initial aids, and it's a parameter for the stability of the organic matter. So it's also for the speed of the decomposition. You have to fill in the CN ratio of the organic matter, and also temperature. These are the three most important parameters. But if desired, you can also add other factors to the model. For example, the influence of oxygen or acidity of the soil. But when the soil is in good condition, often the effect of these factors is neglectable. At the right hand side, you see an example that I made for the mineralization of the organic fraction of cattle slurry and pig slurry. And you'll see there's a rather huge difference between these two types of manure, and that's because the organic fraction in the manure or the slurry of cows is more stable, so it decomposes slower than these of pigs. And also the CN ratio of the manure of cows is higher, and therefore the mineralization is also lower. The farmers, of course, do not have to use this model by themselves, but with this model, we did calculations for several types of manures and several situations, and we put the result of these calculations into tables, and farmers can look it up on the website, Handbook Soil and Fertility. And as you can see, what I just said is that, for example, when you have a crop that with short uptake period, for example, it's ending, the uptake is ending at 1st of July, then you see that in case of this fattening pigs, that only 35% of the organic manure is available for the crop. And when an uptake stops at the 1st of August, then 45% is available. I'll give you an example. So with these figures, how you can make an estimation of this fertilizer replacement value in case of nitrogen. So suggest we have the slurry of this fattening pigs, and it contains 7 grams per kilogram of nitrogen, of which in 3.7 in mineral form as ammonia and 3.3 as in the organic form. You apply it on the 1st of April by means of a deep injection, which is at that moment only possible on a sandy soil. And the next following crop are ware potatoes that are planted at the end of April. Then for ware potatoes, we know that the nitrogen uptake ends, of course, when they start ripening, and this is about at the 1st of August. So we calculate with the end uptake period till the 1st of August. And in the graph before you, I just showed you that about 45% of the organic nitrogen comes available in this period. So you can calculate the fertilizer replacement value by the 3.7 of the mineral nitrogen, and 95% remains available. And the 3.3 for the organic nitrogen, and 45% comes available during the growth period of the crop. Divide this by the total nitrogen content, and then you can say that the replacement value compared to a chemical fertilizer, compared to calcium ammonia nitrate, is 70%. And how we deal with this in the fertilization plan. I give you an example of this. I suggest the demand of potatoes differs per variety, but suggest you have a variety that demands 250 kilograms of nitrogen per hectare. And you apply 25 tons of this fattening pig slurry before planting, let's say at 1st of April. It means that you apply 175 kilograms of nitrogen in total. But then we calculate with a fertilizing value of 70%, which is 103 kilograms per hectare, what would be equivalent to calcium ammonium nitrate. We often try for potato to apply at least 150 kilograms nitrogen per hectare, what we call as a basic fertilization, or 2/3 of the demand. So in this example, another 41 kilograms of nitrogen is applied at the ridge shaping. That's about a few weeks after planting. And then the remainder, that's about 1/3 part, is applied at canopy closure. That will be about end of June or 1st of July. And but at that moment, you also have the possibility, you can say, okay, I apply the remainder 86 kilograms, or you can adjust this rate by making use of a decision support system that we heard about before in the previous presentations. For phosphorus and potassium, no, we do not use a model, but we have some figures for it, or guidelines that are derived from really from trials, for field trials as well as potter trials. So these are more rough guidelines. We know that the phosphorus from cattle manure comes rather slowly available, and if you compare it to triple superphosphate, you can say that about the replacement value is about 60%. For pig manure, it's 100%, because a lot of potassium in pig manure is also present in a mineral form in this manure. And for poultry, 70. For composted materials, it can differ from 60 to 80. But on the long term, we say for the phosphorus balance of your soil, you can calculate with 100%, because on the long term, all the phosphorus from this organic manures comes available. For potassium, it's rather easy. Potassium is not bound in organic substances like proteins or carbohydrates. It's in mineral form in the manure. And when you, after application of the manure, the release of potassium is rather fast, and so we calculate with a replacement value of 100%. So the potassium in manure is comparable to the potassium of chemical fertilizer. When you use a lot of manure and you use it very often, what is done in the Netherlands, I said, yeah, the mineralization from the organic matter, the replacement value is based on the nitrogen uptake period of the crop during the first growing season. But of course, this mineralization continues also in the years thereafter. And in this graph, I show you what, for example, when you apply cattle manure with 80 kilograms of organic nitrogen in it, and then you see that in the first year after application, ample 20 kilograms is mineralized, but in the second year also parts mineralized, and even till the 10th year or longer, there's still some nitrogen mineralizing from this manure. But for example, when you apply it every year, then in the second year you have of course the mineral, when you apply it in year 2, you still have the mineralization of that year. That's year 1, but also the amount that has been mineralized the year from the application of the year before. And so, for example, here in the 10th year, you have the accumulation of all these the mineralization in all these years. So actually, it accumulates. And it means that when you use a lot of manure, that your mineralization level of the soil is increasing, and that gives also a higher risk for nitrate leaching to the soil water and the surface water, because mineralization goes on also after the crop stops with taking up nitrogen. For example, I just told you when potatoes start ripening at 1 of August, they do not take up nitrogen anymore. But at that moment, end of summer and early springtime, the temperature of the soil is still very high, and so there's still a lot of mineralization, and this nitrogen in mineral form accumulates in the soil, and so before wintertime, you can still have a lot of nitrogen in the soil that can leach in the wintertime. Yeah, and how to reduce these losses is for the ammonia volatilization. The best option is to make sure that the manure is well incorporated into the soil. This decreases the volatilization losses. And with respect to nitrate leaching, what we say is there are a lot of points for attention. First, you need to know how much available nitrogen that you have from this manure for the crop. So you have to measure when you receive a manure, you have to make sure that the nitrogen content is measured, and preferably the mineral and organic part of the nitrogen must be measured separately. And then next you have to predict the available amount of the nitrogen for the crop, and so then that you know rather sure how much nitrogen that you give to the crop, and later on you can adjust it with additional nitrogen rates with calcium ammonium nitrate, or when you doubt, when you're not sure about how much nitrogen will be delivered from the manure to the crop, you can use a decision support system. But the first thing that you have to be aware of is that you prevent an overdosage of nitrogen, because all nitrogen that is not taken up by the crop is available for leaching. And secondly, what is now often done in the Netherlands, especially on the sandy soils, is that farmers I would say pushed by the government to grow a nitrogen catch crop after the main crop, and these actually are green manures, but they are not fertilized. But these green manures, when they are sown in late summer or autumn, they still can take up rather a lot of nitrogen before the winter. And when you choose a winter hardy catch crop, then it does not die in wintertime, and all the nitrogen that is taken up by the catch crop cannot leach. That was it. What I want to tell you about how we deal with manure in the Netherlands.
Thank you very much, Willem, for your presentation. That concludes session 2. Somebody was asking about if we're going to share the presentations. As long as the speakers don't have a problem with it, we can share the presentations. And I also remind you that we are recording the event, so that will be available. We're moving on to session 3 now, sowing sustainability, enhancing soil quality for future farming, in which Cecilia is going to speak about techniques like alternative crops, cover crops, carbon farming, and optimizing nutrient use. Cecilia, you're going to be able to explain this a million times better than I ever could. So please, the floor is yours.
Thank you very much, and thank you to all the previous speakers who have given us so much details on and such a good overview of what we are doing, what is going on really around Europe in different kind of projects, different types of good innovations really. So I will start with giving you just a really short collection of practices in the topic of soil quality. And I'll start with saying that cover crops is one of the really popular ones to talk about, of course, when you're talking about soil quality. And this might seem like a really no-brainer, really, but it's used for different ways or for different reasons and in different ways. And it can be for, as we say here, to prevent soil erosion and so on. So that's really something to keep your eyes on, even though it seems like old news, but there are things happening on the cover crops. Let's see if I can give a chat on changing. Here we go. we also have the things to prevent soil compactation, to also increase the soil quality, the soil health really on that. We have nutrient management and recycling. That's interesting because it's we're talking both, as we heard Willem just talk about, both nitrogen and phosphorus, perhaps also potassium, and making it a more circular system, really, as well as here we're coming into bioashes and digestate from biogas plants and all of that. And it's just really an interesting topic of making a farm and the agricultural society a more circular place. And I think that is one for the future as well. We also have crop rotation. Might seem the same way as with cover crops. This is old news, but really there are so many different reasons to do it, and therefore there are so many different techniques as well. So it can be, for example, if you want to have more nitrogen in your soil, you can have a crop rotation system where you introduce something that is binding nitrogen into the soil automatically, and therefore reducing all these synthetic or mineral fertilizers, really. We are also talking about pest and weed control and doing that without chemicals. And there are multiple different examples. I'm not going to go into them in detail, but I know they will be on the STRATUS platform, as well as if you're reaching out to one of us, I'm sure we can all put you in contact if you see something that you want to know more about. And this, to me, is really interesting with a pest and weed control and not having to use chemicals to do that, but rather doing it in a natural way to have a more resistant and resilient soil is really a win-win for everyone involved. I'm gonna go into, as promised, a little bit more on what happens with biochar, and that is where my expertise comes in. That's what I work with, and I'll give you two examples of two field trials. The first one is going on in Denmark, and here we have biochar that, well, first of all, it had a really high pH, so nothing wanted to grow in it. So we had to neutralize that pH at first. But once we did that, we could use it in pots, and we wanted to see the root penetration and how fast that happened. And we, as you can see in the picture, we filled in little like cores, the holes in the middle of those pots with biochar. We also, of course, had sand and clay as controls. And we could see that it actually had a double rate of root penetration in pots with biochar. Didn't matter if it was powdered or if it was more pelletized biochar, but it really helped. And the point of doing that was that we later, this summer actually, in 2024, the past summer, the Danes did it out in the field and wanted to see does biochar actually do something for drought resilience. So they not going to go into the whole technique of what they actually did, but they wanted to see the droughts here. And what happened was that we had a really, really wet summer. So there was just no option of seeing anything to do with drought. It rained the whole summer. As you can see, they even put up some covers to try and keep the rain off the experimental plots and stuff like that. It did not work. So we will try and see the results for next year. But what can be done or what can be said both this experience as well as the next one I'm going to show is that biochar does not have it does not have a negative impact on the soil or on the plants growing on it. So So the next experiment field trial that we did was in Sweden, and we had well, more pilot scale. We had a bunch of fields really that are dry normally. Yeah, same again here. We had a very wet summer. Couldn't really see that much of a drought resilience well, results really from it, but we did use 10 tons, 2 tons, or 0 tons of biochar per hectare. And what you could see here again was that there were no adverse effects, even though it was really wet, and the biochar was not loaded with any nutrients to begin with. So it was just this carbon skeleton that we put into the soil, and what happens then is that the biochar is gonna it works as a sponge really. So if you put a dry sponge into wet soil, it's gonna take water from the soil and store it inside, and then when the soil gets dry, the water is gonna leak out in a nice and even way to be plant available. Same thing happens with the nutrients, but then again, if you have too much water in the season, you're not obviously gonna see that. So we'll wait for next summer, and I can't even say that, but I can't say that we're hoping for a dry summer or a drought, but you know, a little bit I do. And to go into that as well, when we have this, I'm talking about biochar and it should be used in the soil. And then I also say that, well, we couldn't see any results on it. There was no result on the yield. There was no result on plant life expectancy, you might call it, or survival. So why should we use it then? And here we come into the really big questions of climate change and how biochar and soil quality really can be a double win and both increase that soil quality and create carbon sinks. And just to take a step back for a second, what is biochar? I'm not going to go into the details of what it looks like and the physiochemical properties of it, but what I want you to remember is that biochar is a carbon storage, whereas, say, charcoal is an energy storage. That's where you want to burn and you want to have a barbecue. Then you're using charcoal. Whereas biochar, if you put it in the soil and have it as carbon storage, that is biochar. So part of the definition of what biochar is or lays in the use of it, really. And we'll see how much I'm gonna go into this. I'll be rather quick. So shout out if I'm going too quick, or otherwise take it up as a question. But I really want to show you the difference of different carbon cycles and how quickly or how slowly they can move, and why is it important to have slow carbon cycles. So if you have a normal natural carbon cycle, we have a tree, we have photosynthesis, and then it kind of moves in hundreds of years. That tree is sucking up carbon dioxide from the atmosphere, and then it gets broken down, and the carbon dioxide is released back into the atmosphere. That is we call that a quick carbon cycle, even though it's hundreds of years, because we are comparing it to a slow cycle. And here we are talking about millions of years. At the bottom of this picture, you can see oil, and that is what I think will symbolize the fossil carbons. The problem, of course, as we all know, comes in at the top right part of the picture, where this cycle is really, really quick. We're burning the fossil carbons way too quick, rather than just letting it be for millions of years. Then we need to find, because we can't avoid burning fossil carbon for everything. even though we of course need to change how we live our lives. But we do need these negative emissions, and that's where biochar comes in. But here we're talking about thousands of years that it is stable, that is kept out of the atmosphere. It can even be longer as well. Research is, the jury is still out on that, if it's geological timeframes or if it's broader thousands of years, but it's a long time. So when people talk about climate compensation and carbon sinks and fossil carbon and stuff like that, just keep this picture in your mind and think about the tree with hundreds of years versus the dinosaur on the left with millions of years, and see where does that carbon sink or carbon credit fit in. Just to end up with, I already mentioned it, but this is called a negative emission. Of course, we need to change how we are living. We can't do business as usual, but we also need the net negative emissions. And I think this is really interesting coming into, we're talking about both small projects and really not small, but details in soil quality and in agriculture as a whole. But we can also talk about the really big questions as climate change and what the UN is talking about every single year, and what is really our biggest crisis on this earth at the moment. And we can have a real impact on that as the agricultural society is. So I think I'll stop there and leave it back to you, John.
Well, thank you very much. It's time now to answer the questions that you have about those three presentations. I believe we already have some questions, so if all the panelists want to come back, open their mics, open their cameras, and Cecilia, I will leave it to you to moderate the session. And Sonia, you have some questions already?
Yeah. Thank you for those ones who were presented and for those ones who brought their questions to the chat. Some of the questions have already been answered, so I'm not going to take those ones, but just very recently on your presentation, Cecilia, there is this question: have any of the trials or studies tried a combination of biochar and mycorrhizal fungi? Supposedly this is a great way to accelerate humus formation.
Yes, this is a very great topic, and it's a good question as well. It has been done. There are some techniques where you can apply the biochar together with the seed as well as the mycorrhizal sludge, really a sludge of nutrients and mycorrhizal fungi. So yes, not in the two trials that I showed you today, but it has been done, and it is being done in different at different universities. Definitely, it's a good question. Thanks.
Okay. Thanks a lot, Cecilia. Yeah.
Yeah, were there any more from the chat that we should start with?
There is some more questions to Willem van Geel. What kind of catch crops do you use in the Netherlands?
There are several, but it's winter hardy cash crops that are used is the winter rye, for example, which also, of course, is a main crop, but it can also be used as a catch crop. And Japanese oats is used. Also, winter barley can be used as a catch crop, and I think and Italian and English ryegrass.
Okay. Thank you. Thank you for this. I have a question for Simone, which was brought before, and this is: which innovative traditional fertilizers have you selected?
Sorry, I didn't understand.
Yeah, which either innovative or traditional fertilizers have you selected?
We gave the maps to the binaries in that case that I showed before, and they used the traditional fertilizers. So the aim was to optimize the distribution of traditional fertilizer.
Okay, well, thank you. I think those were the questions in the chat for the moment. Other ones have been answered, but we had some questions that were brought to us this morning by some of the participants. And I don't know if you would like to address these ones now, Cecilia, if that's okay with you.
Yeah, go ahead. Go ahead if you have them in front of you.
Okay, this was one about biochar, and this is there any way or any time that biochar should not be used?
Well, depending on what kind of results you want to have from the biochar when you apply it can definitely have a bigger or smaller impact. So the biggest impact you'll have is, as in these experiments, we wanted to try the drought resilience. And if you have dry, arid areas or a rather poor soil, then you will see a bigger result on your yield. Whereas if everything is already perfect, you have the perfect amount of water, you have the perfect amount of nutrients and mulch and everything of that, then of course you will have the carbon sink and you can sell the carbon credits if they are certified, but you will not see a big difference in the yield. Then of course it can be used as well as for more or less an insurance if you do have drought. But I would say that rather use it where it is in poor soils where you already have problems. Thanks.
Okay, thank you. We have another question to Georgia. How do the costs and return on investment of using drones for precision fertilization compare to traditional fertilization methods? Well, especially for small-scale farmers.
Yeah, good question. Let's don't forget that we are talking for fields, and the fields are small businesses. So it is very important when we have especially a small-scale field to understand if buying a new technology in general, and especially a drone for monitoring the crop, it is necessary. And if we could have, let's say, depreciation really quick. So, in my opinion, as when we are talking for small scales, or if it makes sense or not, or it will be a good business activity, it is very important to have an economic analysis. And this is something that, of course, the advisors could do. Because it always depends on the different crops, what we mean from a small scale or different countries. So I would say that it depends. If after an economic analysis, we understand that, of course, we don't have any additional value from using these new technologies, in my opinion, there's no reason to apply it. However, in the future, of course, we are waiting to be more necessary. So I think that it is better if you want to use it to find small groups of farmers or corporations that could buy the new technology and use it in small groups.
Okay, that's clear. Thank you very much. I think there's a question in the chat for about biochar, but I think we are needing some explanation on what the HAP stands for, if I'm not wrong, Cecilia.
Yeah, that would be good, just to make sure we polyaromatic hydrocarbons.
Yeah.
Thank you. Well, it's kind of always leaks a little bit from depending on what kind of biochar you have. So if you have something that is having a lot of potassium in it, that's a completely different thing, I know, but then it will leak out. And if you have, I have not heard about the polyaromatic hydrocarbons, but yeah, it is possible, definitely. Although a lot of other problematic things in soil is rather tied and bound quite hard to biochar. So it usually has the opposite effect that, say, for heavy metals or PFAS or stuff like that, it will rather bind in and not be released and not be plant available. But on this topic, I will have to look it up. So good question there.
Okay, thank you very much. We have a bit of time, so I would like to ask Alexandros if you could maybe tell us a little bit about the challenges you faced when implementing your study case.
Yes, thank you, Sonia. So when we're talking about crop monitoring in a scale like this, there's a lot of moving parts and a lot of complex elements, which means that we don't only have the flight of the drones taking images with its camera, which are hyperspectral images or multispectral images. We also have analyses for the soil. We have leaf tissue analyses. We have a lot of different kinds of data that need to start, modularly coming together, which is a very difficult thing, especially when we're using algorithms and data models. We have to make sure that everything is not biased and everything actually contributes in some way or the other without actually having the influence of just the cameras, of the hyperspectral images, or just the soil analysis, and so on and so forth.
Okay, thanks a lot, Alex. Okay, I think we do not have any other questions, but I want to give the floor to Cecilia in case she wants to address any issue, any comment, any topic that, as an expert in the whole event, you want to highlight or so. Otherwise,
yeah, I'm thinking just to go in on a little, because we heard a lot about the drones, and I think that is so interesting. It's really a futuristic technology. And so this question is perhaps for both Alexandros and Simone. What do you think in 10 years' time, will drones be a common thing to see in the landscape, or is it a fling that we are talking about and using a lot now, but it's gonna die down? Just a short comment on that. What do you see in the future? Let's start with Alexandros.
Yeah, very good question, Cecilia. The importance and the value that drones have cannot be understated. It truly is. I truly think it's not a fad. My only issue is in 10 years' time, at least in Greece, where we are conducting our experiments and trials, is the regulatory policies and things like that that are genuinely hampering all these operations. It is actually very difficult to be able to conduct experiments. And we're not talking about commercially applying all these practices. We're talking just experiments. You have to go through special permits and talk with ministries, which makes it really difficult to be able to bring it forward in an actual commercial setting. So 10 years time, hopefully we will have solved all those different policy and regulation things.
That's amazing. And Simone, do you think that we will see drones buzzing around over the fields in 10 years' time?
Yes, thank you for the question. From my point of view, I think that the drone is a tool. So like a smartphone is a tool, a weather station is a tool. So when we start to appreciate the capabilities and how it's powerful to monitor and to get information, both in automatic or also manual way, but I think that yes, from the point of view of the law and bureaucracy, for example, in Italy, but in Europe in general, it's much easier now to apply drones in agriculture than, for example, 10 years ago. So I think that, yes, of course, as also for other application, the law it's in late with respect to technology, because right now we have also, for example, drone in a box, so you can also control a drone from everywhere in the world. But technically, from the point of view of the law, you cannot use it. So I think this is a discrepancy that you often see when you talk about technology and innovation.
Of course, that is always coming a little bit on the back foot, and will follow the technology coming into it. Just I think one finishing question. I want to bring Alessandra in to the conversation again, because you talked a lot about partnerships and having such in both really high level EU Horizon projects like this one, as well as partnerships with smallholder farmers and small businesses. Do you have any short tips on if the people in the audience and us who are listening today that want to create that kind of successful partnerships that the Tuscany region is so good at doing?
Okay, the S3 platform is a platform for smart specialization strategy, and in that we have innovation with TRL. So that means that they have a financial help if you are in a certain level and not short level. For the small farmers, that's important because with that we can implement all the information and the innovation to spread as much as possible with other instruments and not with the platform. But platform is very important for my side because we may have exchange of information, and we have also the pilot cases that we can spread all over the member states, the member countries. I mean, we had before a fruit, a kind of fruit detective that in Greece, they with American Farm School wanted to try and implement on viticulture for grape, for fruits, not to make wine, but they have been very useful. And
That's good. That's a good example, and I think the whole platform state of mind is important to bring people together on a platform where you can talk to each other as peers, right? And now, John, do you guys want to one break for the next part?
I think we have one more question in the chat, and I think after that we can close the panel and move on to the next session.
Yeah. We will take the last one, which is basically for, I think, drone experts. Is there any strategy, policy, or project aiming to take into account and improve the environmental performance of drone construction, like rare earth metal or batteries, non-recyclable composite materials, or so on?
Sorry, Sonia, I didn't understand if you the beginning of your question.
Okay, if it happens to be, or you are aware of any strategy or policy or project that is aiming to take into account and improve the environmental performance of drone construction.
Yes, with community of practice, we have joint construction, and inside that we have groups that are working on different topic. For example, fertilization, and also we have we financed many projects on precision agriculture with rural development project.
Maybe Alexandra and Simone, do you have any input on that question as well for the drones?
No, actually, to my knowledge, I don't think there is an improvement on that side or a strategy or a policy. Of course, all the drones has to be EU certified, as also other objects. But yes, it's I think an important question because yes, we are talking a lot about the rare earth metal and batteries. And so, yes, could be a problem in the future. But I think on that side, to my knowledge, there is no specific policy or strategy to contrast the use of alternative materials.
Perfect. Thank you. And Alexandros, do you have a comment on it? If you have any new input.
I don't know if it's possible to have. Sorry, do you want to finish, Cecilia?
No, go ahead. And then I wanted to give the floor to that question to Alexandros as well.
Okay. No, I was curious if it's possible to have a drone with the solar energy. Will be too heavy, or already exists, or what?
Perhaps I'll send that question to you, Alexandros, then if you know it.
I think Simone is more qualified to answer that, actually. So.
Oh, yeah.
Yes, already exists some drones with solar panels, but not commercially. So are something that are from a research point of view, and also because you need very high surface to have a solar power to move a drone. So there are some drones, but bigger drones. Also, I don't know if you remember some years ago, I don't remember now the exact name, but it was like the Solar Pulse drone, which was a very big drone, with very big wings, with solar panels, and it could stay in flight for like hours and hours. So yes, there are some applications, but if you go to smaller drones, so the one that we commonly use in also in agriculture, also in other application, no, right now there is not that application.
Good, thank you. Then we had an expert answer on that, and with that, I think I will leave it back to John and Sonia for the end of it.
Yeah, thank you very much. And thank you to all the panelists for being here, for presenting. That was a lot of information. I'm glad that we could have this dynamic panel discussion. And now for the next 10 or 15 minutes, we're going to present some of the first results from the project STRATUS. And for that, I'd like to bring Clemence, who is going to give us a presentation. So Clemence, if you want to turn on your camera and start sharing your screen, the floor is yours.
Yes, so let me know when it's full screen. Is it full screen?
No, not yet.
Yes.
Now it is. Perfect.
Okay, so I'll try to be quick. Thank you. So many things were already said, but yes, in the STRATUS project, we collected during the end of the year 52 good practices and research innovation. So some of them were already mentioned before by the other panelists. So what I want to say is just that we gathered practices that come from the field and innovations that comes more from publications. And so we want to do another round of collection by the end of the year 2026. So then with these practices gathered, we will estimate what are the best. So best practices, we will gather 48 of them, and then they will be disseminated all across Europe thanks to cross-visit, demonstrations, and training courses, especially gathering advisors. And then advisors will be able to explain them, disseminate them to the farmers all across Europe. So this is what we plan to do in this project. And regarding the first practices that were gathered, as you can see here, they are either regarding biobased fertilizers, either precision farming, either soil quality. So in these three subgroups, we made 3 microsource forms that were filled, and then we did some quality check and some translation. So all of the practices that were collected, they are translated in 11 languages. So this is a very good information for you. Maybe if you want to follow the STRATUS project on LinkedIn, for instance, and then in July this year, they will be available in your local language normally. So each language is of the STRATUS project, but normally it will be in your languages. It will be in English at least. So that's the thing. So here you can see, for instance, sorry, it's in French, but this is what we gather. So for instance, 4 pages explaining one practice. So one practice can be the use of drones, for instance, to make it simple. And you have information about how it was implemented in the local conditions, why it answers to some farmers' need, and how does it take in terms of logistics to implement it, what are the agronomical interests, and some administrative context like subventions that you can have, and then a contact. For instance, it will bring back to Cecilia or anybody who implemented the practice in these sheets. So all the sheets will be available online. And now, very shortly, I will present the titles of the practices that we gathered. So this is the first group. It is regarding fertilizers. So I tried to make subgroups just to give you a first insight of what we gathered. So for instance, we can see that there are in a range some organic inputs that you can put into your field as fertilizers. So there can be, for instance, manure. Then you can have biostimulants inputs with different composition. It can be with microbe or not. Then you have the biochar, as it was already explained before this morning. But you can also have some mineral inputs. So, for instance, for this, it's very specific. It's interesting. It's ammonium sulfate that you can get from from livestock. So it's very specific. And then in dark green, you can see that so you can also check how to optimize the use of fertilizers thanks to precision farming. Like soil analysis, but also silage analysis and all of these things. So I will not go further into details. These are some examples. Now, regarding the second subgroup, it is related to precision farming. So it's hard to make subgroups here because a lot of information in the subgroup is about use of satellite data, and then create yield maps of your farm, and then do variable dosing of fertilizer spraying. So what is interesting is you can see in the first paragraph here that depending on the country, you have different suppliers of apps, of applications. So I wrote here all the companies that provide applications. So some of them are free. So you can have an insight of what to use in your own field. And then second paragraph, you can see that not only satellite data, but you can also use drones for the same purpose of creating yield maps. And then you have some others, for instance, the use of sensors, which is not directly connected with yield maps here. It's more close to the field. And then other /manure, it's regarding precise adjustments of the manure spraying. Now I can give you some specific insights into one example. It's this tool. You can see that you can use some smartphone, very simple camera. Take a picture of your plants or group of plants in the field, and then you can have the specific leaf area very quickly measured and some information about the biomass in your field. Thanks to this, you see it's very close to the plants. It's not connected with satellite data. Then, to finish with the last and third subgroups, it's regarding soil quality. I can think about 4 subgroups. For instance, you can improve soil quality using inputs that can be most of them manure, silage, and also the plants. For instance, you can use some plants that you grow and that will just stay in the field or go to another field in your own farm. Also biochar. Then you can use digital technologies to optimize soil quality, but also you can try to reduce soil cultivation using strip till. You can try to prevent compaction problems in your soil too. And the last sub-paragraph you can see is agronomic practices. And for this, you can, for instance, work on your crop rotation. It will give you a better soil quality at the end. So here is an example of how to reduce soil compaction problems. And to finish with, for instance, you can have this, which is in your rotation, try to improve the quantity of grass, to modify the ration of your cows that will be eating the grass, and then have a better quality of manure directly in your farm. So it's a win-win situation at the end. So as I said, inside the project, there will be demonstration and cross visits and trainings to train the advisors. But it will not only be inside the project, it will be outside the project. So you can get insights about these good practices by just going to the web platform. So please just follow the project, and by July, you should have all of this information available. Thank you.
Thank you very much, Clemence. So that concludes all of the sessions that we have for today. We're going to pass it on to Paula to give the closing remarks. And
Yes.
Thank you very much to everybody for being here. Paula, the floor is yours.
Yeah, I will try to keep it really short since it's already really late. Just to recap, in the precision agricultural session, we talk about the democratization of precision agriculture, a very important aspect, because in the adoption of innovations by farmers and advisors, it's really important that they are accessible for them to use them. So, for example, the AgroBit project, I think they were interesting because they have used low-cost drones, only RGB drones, and have obtained many metrics out of these images. Also, in the same line, Icarios project is also helping the adoption process by doing market research, training, and so on. It's necessary to consider the legal limitations of using a drone, which in fact is an obstacle to its use. Hence, the importance of governments to be involved in the agricultural sector and all of this process of the adoption of innovative solutions. This related what Alessandra explained to us, how the government of Regione Toscana involves in the adoption of new innovations and digitalization in agricultural sectors. So some experts, experts are confident that maybe in 10 years we will see drones as a common day-to-day tool for farmers, but we will see. So regarding manure management, it's really important, especially if a region happens to have surplus. Williem explained really well in detail how they manage this in the Netherlands. As in many member states, the max amount a farmer can apply is limited. Arable farmers got paid to use it, and this makes it more attractive. I think this is really interesting. I'm not really sure that in other member states happens this. So he mentioned a problem, that the fact that the fertilizer recommendations are based on chemical fertilizers. So they are using fertilizer replacement value of manure, which is, if I am not wrong, an equivalence between a mineral fertilizer and manure that leads to the same yield of the crop. Williem presented also a handbook for soil health and fertilization. It's a tool for farmers, and again, sharing a lot of good practices, really ready to use, and recommendation and about how to apply manure and in the way they do it in the Netherlands. And then Cecilia highlighted the value of applying biochar for drought resilience. Also, because biochar could be a double win, because it can be seen also a carbon sink, not only improving soil quality. And about all of these topics we have been talking, as Clemence just right now presented to us, we have been collecting good practices and research innovations across different member states that work well, and about these different 3 topics, and there will be available in July 2025. Besides in July 2025, we will have up and running our digital platform. This digital platform includes training materials, inventory of practices, and a networking component from different projects, not only our project that addresses optimal fertilizers use, also LiveNet, which is about livestock, advisory net pest that addresses pest management and pesticides management, for advice about forestry, and organic advice network about organic farming. So if you're interested in our project and you enjoy the topics we addressed today in this event, follow us in our social media to keep updated about the launch of the platform and also the collection of good practices and more. Again, many thanks to you all, also for the presenters for today's work, and I hope you enjoyed the event. Many thanks.
Thank you very much. Well, thank you very much, everybody. Like we said, this is being recorded. We will share the link with everybody that attended. If the speakers are okay with it, we will also share the presentations, and we remain available to anybody for any questions that you have about the project. Thank you very much.
Thank you.
Thank
Thanks,
you.
everybody.
Thank you.
Thanks.
Bye.
Thank you.
Bye.
Bye.
Thanks, bye.